friends, we are bigdatahands-on.com. Today is day 31. We are going to see convolutional neural networks using keras. Previously, we have seen yesterday only we started the deep learning. So we covered artificial neural networks, introduction to deep learning, and from day 30 to day 40, we'll cover deep learning sessions. So all the previous sessions we have taken machine learnings. Also, we have taken many videos and in Python and statistics and probability. All the videos you will find in down our YouTube channel, bigdatahands-on.com. If you subscribe to our channel, you will get all the notifications. Okay. So our website bigdatahands-on.com. You can visit our website. If you have any doubts, you can message this number 979928424, or you can send the email to support@bigdatahands-on.com. Okay. So today's topic is convolutional neural network. Let me jump into the today's topic. Deep learning CNN, convolutional neural network. So why we need the convolutional neural network? So initially the convolutional neural network is created to handle the image data. Okay, so because in image data we have a large data, right? It's a huge data. So to classify the images or to recognize the images, we have to compress the images, right? So let's say if you have a 128 by 128 image, it's too large, right? So the features is very large. So that time our model will not perform good. So what we'll do is we'll compress the image into a lower dimensional. Okay, but still it contains the important features. Okay, like the dimensionality reduction, what we done in the large data, we reduces the dimension, right? But still it contains the most of the information. So like the same way we'll use the CNN to compress the images, but still it contains the important features. Okay, so that's why we have the CNN, convolutional neural network for images. Okay, so convolutional neural network, what it does is, so you can see here we have the input layer. This original image, you can say 36 by 36 image. So now what we are doing is we are compressing into a lower dimensional 26 26. Okay, and again we are compressing this layer called max pooling layer, so it will compress again. So we are converting 12 by 12 and again 6 by 6 and again 2 by 2. So now that the data is become a lower dimension, 2 by 2 by 3. Okay, so now what we can do is we can give this data, the compressed data, to the ANN. Okay, and we can classify the image. So this is how the whole process of CNN is going to be. So CNNs operate over volume. Traditional neural networks are not ideal for image processing and must be fed images in reduced resolution pieces. Okay, that's what the convolutional is about. Okay, convolutional neural networks are powerful image processing artificial intelligence that use deep learning to perform both generative and descriptive tasks, often using machine vision that includes image and video recognition along with recommender system and natural language processing. So these are the fields we'll use the convolution neural networks actually. Not only images, in the generative and descriptive tasks and machine vision, and if you want to recognize image, video, or recommender systems. Actually, in recommender system also we use the convolutional neural network. So we'll see that in the upcoming sessions. Okay, and in natural language processing also we are using the convolutional neural network. Actually, the whole concept of convolutional neural network is to reduce the resolution. That's it. Okay, resolution of the image. So before that, we need to know about the image, right? So if you have a black and white image, that will have only two colors, black and white, right? So the image will be like 2 by 2 matrix. So pixel 1, pixel 2, pixel 3, pixel 4, like that. Or if you have a colored image, that maybe have three channels. So like RGB, right? Red, green, blue. So it will have three channels. three each and every channels has a value between 0 to 255, right? So this what the colored image which we are going to use the same image, this type of image only colored image, right? So in colored image we'll have three channels, and each and every channel has 0 to 255 values. Okay, so CNN steps. So step 1 is the convolutional, and step 2 is the max pooling, step 3 flattening, and step 4 is actually step 4, it is full connection. So we have the convolutional layer, it will compress the image, and again the max pooling layer also compress the image. Flattening layer will convert into a single column, and after converting that we'll fed this data to the ANN model. So the full connection is nothing but our ANN model. Okay, so the compressed image will fit to the ANN, and this ANN model will classify the image. So okay, let's take the smile image. So what we are doing is we are just putting one where the important feature is. So we have eyes, uh, we have a smile here, so there will be ones in the image, another will be zero. So we are taking a sample image. Okay, so using this I will be demonstrating you the convolutional max pooling process. Okay, so let me open this slide. Okay, not okay. So this is the uh, actually the calculation we are going to do is for convolutional layer. So this image we have seen in the slide. Okay, what we are going to do is we are going to compress the image based on the filters. Okay, so the given filters will filter the important features from the image. So this 3 by 3 matrix is nothing but a filter. Okay, likewise we will have multiple filters. Okay, so and we are setting stride equal to 1. So I will tell you what is stride actually. So what we are doing is in the image we have filtered the size is 3 by 3. Okay, so we take a size of 3 by 3 matrix in the image. Okay, like this, so highlighted in the dark color. Okay, so we take the 3 by 3 matrix in the image, and we have the filter. What we do, we'll multiply the each and every element in the corresponding elements in the matrix, and we'll add up all the values. So if you want to see the multiplication, you can see here. So like this, so we are taking a 3 by 3 matrix in the image, and we have the filter. We'll multiply the corresponding elements like 0 into 0, the first element into first element, the second element into second element, like that. We'll multiply all the values and add the values. So that will be the result. Okay, so that is one here. Like that, if the stride is 1, what happens is in the first column it will move one column. So you can see the next step it is moved one column, right? And then again it is moving one column. So like that it will move one column. And if it can't move in the columns, then it will come down, so one row down. Now it is one row down. Again it will go, again it will move one column. Again it will come down in the one row. So like that it will goes on, and we'll multiply each and every value. We'll get in the result we'll get a filtered image. So the input image is 7 by 7. The filtered image we got is 5 by 5. How we got the 5 by 5 image? There is a calculation to find the image size, the result after the convolutional. So you can see here, n plus 2p minus f divided by s plus 1. This is the equation to find the size of the resultant matrix. Okay, so how to calculate is the n is nothing but the size of image, so that is 7 by 7, you can say. So n is 7 now. And then padding, so p is nothing but padding, so we don't have a padding actually. So the padding is 0. 2 into 0 0 minus f. F is the size of filter. The filter is 3 by 3, so you can put 3 here and divided by s. S is nothing but the stride. Okay, so plus 1. So if you say n is 7, 7 plus 0 minus 3 divided by 1 plus 1. So then what happens? 7 minus 3 will be 4. 4 divided by 1, it is 4. 4 plus 1, 5. So you can see here our resultant matrix also 5 by 5. Okay, okay, like this we'll do for multiple filters, not only one filters. We'll have 16 or 32, 64, like that we'll have. Okay, so this is the process of one filter. Okay, now we'll move on to the next slide. So you can see here, so we'll take the 3 by 3 window and we'll multiply with the filter. Then again we'll have the feature maps here, the convolutional. After the convolutional we'll get the compressed images. Okay, after this convolutional we'll give the data to the, what is this? This is an activation function here. So rectified linear unit, you can see, right? So we'll fed this resultant matrix to the activation function. Okay, after this what we have CNN pooling layer. So after the convolution we'll have the pooling layer. So a pooling layer is another building stock block of CNN. Its function is to reduce the dimensionality of the data, and pooling layer operates on each feature map independently. The most common approach used in pooling is max pooling. So we'll see what max pooling is. Okay, the pooling layer is a method to tell the neural network that we expect this invariance. So what it does mean is, so you can see here we have three images, right? The three images are smile images. The human brain can understand that. Okay, but how to tell the neural network these are the same smiley face only? So there is an invariance, right? So over the images we have some invariance. So to tell to tell the neural network that we expect this invariance, we do that by building a network that cannot be sensitive to these small changes. Okay, so if it is sensitive to the small changes, it cannot predict is a smiley face, right? So it's a handwritten face. Uh, it cannot, if it is sensitive, it cannot predict the handwritten smiley face, right? So the convolution layer tries to identify some important structure in some region of the data, while the pooling layer obscures the exact location of the structure. We use invariances in the data to reduce its dimensionality. Okay, so now, so you can see here first is input image we have, and then convolutional layer, and then we have a max pooling layer. You can see the image size is very the compressing. Okay, so let me okay, so now we have the, let me go to the pooling sheet here. So this is the pooling sheet here. So in the pooling sheet, in the first we have, what we have stride equal to 2, right? Okay, and then in the max pooling, so we have max pooling or we can have, I think, many pooling layers we have. So usually we use max pooling only. So max pooling is nothing but, if you have a, if you are giving the size 2 by 2, then we'll take a 2 by 2 matrix in the image and we'll find the uh, maximum value. Maximum value, I think average value also we have average pooling, and likewise we have all the pooling layers. Okay, so max pooling, in max pooling we'll take the maximum value of this matrix. So the maximum value is 1, and if that is stride is 2, we'll move 2 columns, right? We'll moving 2 columns, and then again we have the 2 by 2 matrix. We'll take the maximum value, that is 1. Again we are moving 2 columns. We have 0 0, the maximum value is 0. So likewise, and now after the columns we'll move 2 rows down. 2 rows down we have now. So 1 0 1 4 we have. So the maximum value is 4, so we put 4 here. Again we'll move 2 rows, sorry, 2 columns. So the maximum is 2. Likewise, we'll get the compressed image here, like, right? So we have 110.421.021. So this is very compressed now, right? But still it is having the important features like the convolutional layer. The result of convolutional layer, we got some important feature, right? So again, if you compress, again we have the important features in our image, right? Okay. So now, the third layer, the third step, the flattening layer. So the flattening layer is nothing but converting the two-dimensional or three-dimensional metrics to a one-dimensional, like this, a single column, right? So what we do is we just convert this 2 by 2 into a single column, like 110.421.021, like that. So this is the input features of our ANN model. Okay, so you can see after the pooling layer, we'll flatten this layer, we'll have the features, the input features. Okay, so these are the input layer of a future ANN, artificial neural network. So the steps we covered previously. So you can see input image, convolutional, and then max pooling, and then after the pooling layer we'll flatten the image. Okay, this now it is a input features for the ANN. So this is the process of CNN. After this, the usually what we do full connection. Full connection is nothing but creating the artificial neural network we have seen yesterday, right? So the same way we'll create. So we got the input features, and we'll put one or more hidden layers, and we'll have the output layer, right? It tells happy face or sad face. That's it for CNN. So now let uh, let's see the implementation. uh, so first I will so you can see I have the dataset fruits here. So in the fruits we have apple, banana, mixed, orange. So in every uh, fruits we have nearly 95 images. Okay, so the images of apple, like images of orange, the images of banana, right? So we'll have the images. Now we are going to create a model that will predict whether that is apple or banana or orange, or that is mixed fruit. Okay, so first what will we do, I will open my spider. So for the resource for the data, you can find the data set in Kaggle again. So you can go to the data tab. Wait. Yeah, here we'll search for, sorry, I forgot to put you. Fruits. Yeah, here. Fruits. I think this is a huge data actually. Yeah, here I think fruits image. Yeah, I think it's a small image, small data actually for us. We have huge data also. I think this one. Yeah, this one only. Yeah. So this data set only I'm using. So not a very huge data. It's 27 MB, 29 MB. Okay. So So now we have now we are in the spider. So what we'll do, we'll create a new file and save this file in the directory where the data is. So the data is in the uh, in this folder we have the deep learning. Here we have the data fruits. So now we'll save this file as cnn.py. Okay, so let's start creating our model. So we have the data in the folders, right? Now we have the data in folders, so that are images, right? So to work with the images, so we have a library called pillow for the image processing in python. We have the library pillow. uh, so you can import it from pil. Okay, so pil is the pillow, and inside the pillow library we have the class for image. So we do the uh, process whatever the pre-processing for images we do with this class image. Okay, and then we'll import pandas as well. Why we need pandas? I think we don't need the pandas, so we need numpy actually to convert it to array. To work with arrays we need numpy, and to visualize the image we need matplotlib. Okay, and then what other libraries we want? I think, yeah, we want the os library. OS is because our data it's inside the folder. That folder is inside our machine. To find the folder and go to the folder and read the data of images, we need the OS library. Okay, so initially what I'm going to do is I'm going to create a list here called images and labels here. Okay, so the images and labels will append here in the list images and labels. Okay, so now what I'm going to do is I'm going to run a for loop. Okay, so this for loop will go through every folders in the fruits folder. Okay, so before this I will just run run these 4 lines first. We'll import the libraries, and then here if you go to the files you will see the folder fruits here. So we'll create a list for images and labels, and we'll run a loop for, let's say, label here, because the label is nothing but the name of the folder. So you can see apple is the label, banana is the label, mixed is the label, orange is the label. So the labels are the names of folder. So I'm just saying label here, and then the label in os dot. If you want to list the directory, list nothing but, so if I list the directory fruits, then what happens is it will give you the list of folders names in the inside the fruits folder. Okay, so I'm just going to list the directory. The directory is fruits, right? Yeah, so now the label contains the name of the folders, right? So now what I'm going to do is I'm going to run a loop again I'm going to run a loop. So it will go through the inside the apple folder what are the images we have, and then it will read one by one images, and it will store the images inside the list, in the images list. Okay, so this loop will be like this. For let's take it as img image in, again we are going to list the directory, right? Again we are going to list the directory. Now in the list directory you want to give fruits first. Okay, so you want to give fruits first, and then in the second question you want to give the label. Okay, let's go into the folder, into the apple folder. and read the content, what are the files we have. So that files is inside the img uh, variable. Okay, so now what I'm going to do is I'm going to create an object of the image class. Okay, in this image class I'm going to call this image class. Here you want to give the path of the file. So that is os dot path dot join. Oh, I think actually in the list directory itself I want to give the os dot path dot join to join the path, because it is two separate path here, fruits and labels. So to join the fruits and labels we'll use the os dot path dot join. Okay, and then it will list the directory. Now we have the image os dot path dot join. Here you want to give the fruits first, and then label, sorry, and then you want to give the image name, that is EIMG, right? So and it will read the image and will create an object of the image class. So now you can do whatever pre-processing step for the image you can do here. And the pre-processing step is nothing but resizing the image and converting into the RGB mode. If the mode of the image is not in the RGB, will convert into RGB. If the mode is not RGB, sorry, oh, okay, RGB. If not RGB, then we'll convert image equal to image dot convert to RGB. Okay, we'll convert to RGB now. And then the next step will be resizing the image. So why we want to resize is, the every image if you are seeing, the 96 images will not be the same size, right? The same dimensional. So we want to force the image should be in the same dimensions. Okay, so to do that we'll resize the image on a fixed size. So I'm going to resize the image the size of, let's take resize, sorry. Okay, I'm going to resize the image with the 64 by 64. So if the image size is increasing, it will take more time to create train the model. Okay, so that's why I'm just putting 64 here. This one also huge for me, for my system requirements. Okay, so if you have installed the GPU installed in your system, you can have more size, right? uh, but in my machine I don't have GPU, so I'm just giving a small number of image size. Okay, after resizing the images you want to convert into the array. So I will just say np dot array of the image, and then it will give you the array of the image. And this array I'm going to append in the images list. And just start append the array. Okay, and also the labels as well. Labels dot append the label. What is the label? Yeah, label here. Okay, let's run this. It will take some time to read the files actually. Let's wait for some time. What happens here? Yeah, module object is not callable. What is here? Oh, sorry, I think it's a module. inside this module we have the function called open. So yeah, I just forgot it. This is a module actually image, and inside this we'll have the open function. Yeah. Then what is the problem here? Labels is not okay. I misspelled this one or this one. Yeah. Yeah, now it is reading the files. It will take some time. So in the meanwhile, what we do is now after this step, yeah, now uh, the process is finished, the reading process. Now if you go to the images, you will see the numpy arrays 64 comma 64 comma 3. That's an RGB channels here. So we have three channels, right? So these are the datas here. Likewise we'll have I think 300 yeah, 300 images we have. Okay, so after this step, after the reading the data set, we want to normalize the images. So normalization and standardization is the two different methods. So in the standardization, what we do is we calculate the mean and the uh, standard deviation. But in the normalization, usually the ranges of the normalization will be 0 to 1, but in the ranges of the standardization will be a different ones, like it can be -1 to +1, or it can be -2 to +2, -3 to +3. So it will change, right? Depends on the data. But normalization is not like that. It's uh, uh, have the same scale, 0 to 1. Okay, so to convert the images into 0 to 1, what we can do is all the images have the range between 0 to 255, right? I said before. So we can uh, divide the okay before dividing it, I will just convert into array. Images equal to np dot add because it's a list now. I will convert into array. Okay, so for the labels as well, after converting into uh, arrays, what I'm going to do is I'm going to divide the images with the 255. Uh, now it will be a normalization, right? Because the scale of the images will be 0 to 1, 0 to 255. If you are dividing it with 255, then the ranges will become 0 to 1. So that's why we are doing here. And for this labels is now a categorical one, so we have to encode these categories. So let me import the label encoder in the sklearn dot pre-processing. We'll import the label encoder. Okay, we'll create the object lb equal to label encoder, and we'll fit the label encoder into the y. lb dot fit transform of the labels. Okay, that's it. Now we have pre-processed our images and labels. Now it's time to split the dataset into training and testing. Okay, so to do that, we'll import the train test split from sklearn library model selection module. So this will return four values: x train, so we know that, right? X train, x test, y train, y test. We'll call the function and give the arrays, that is images, and options are the labels, and we give the test size. I think not images, it's x actually, x and y. Okay, and we'll give the test size as 0.25 as we do usually, and we'll set random state 0. Okay, and that's it. So now let's split the data set. So now we got the x train x test, y train y test data set. So after splitting the data sets, it's time for building the neural network, the convolutional neural network we are going to build, right? For that we need some classes, so we'll import it from keras, right? So the first class we need is uh, inside the sorry keras inside the keras library we'll have the models module. Inside the models module we want to import this sequential class. It's very important to build the neural network. And the next class will be the layers you want to import, because we have a convolutional layer and max pooling layers, right? So first we'll import the convolutional layer, convolutional 2D, and again we'll import the max pooling layer. So you can see we have max pooling, and we have various pooling layers actually. Convolutional max pooling, and yeah, we'll import max pooling layer, and we want to import a dense layer to create uh, full connected layers. So we'll import the dense layer, and again we want another layer in between the max pooling and fully connected layers. What we do, we'll flatten the layer, like flatten the image. So to flatten the image we'll have the layer flatten. Okay, so these are the four layers we have imported: convolutional, max pooling, flatten, and dense. So now we'll create the model equal to we'll create the sequential model, right? So we'll call the class sequential. Now after this, using this object you want to add a layer. So we'll add a layer. First layer will be convolutional 2D. Okay, in the convolutional 2D what you want to give is it takes some parameters like the filters, number of filters it takes. So you can see here filters, kernel size, strides, padding, data format we don't want, kernel initializer, and input shape we want. Okay, what we do, we'll give filters now. Filters equal to uh, initially let's take 16 filters, and then we'll increase 32 and then 64 like that. So it's not that you will have only one convolutional and max pooling set layer. So we can have multiple convolutional and max pooling layer. Okay, so the next parameter I will pass the kernel size. Kernel size is nothing but filter size actually. So we'll give 3 by 3, so 3 by 3 kernel, and then we'll give the input shape. Okay, input underscore shape. Input shape is 64 by 64 by 3, right? Okay, and then what we have, you want to give the activation function, maybe you can give actually. So we'll give activation as relu. What is this? Okay, so now what we do, we'll add another layer. Now the layer is max pooling layer. So in the max pooling, just you want to give the size of the filter, so you can just give 2 by 2, that's it. Okay, this will be max pooling layer. So it's not that you will have only one max pudding and convolution layer, we can have multiple set of convolutional max pudding layer. Now I'm planning to have two set of convolution and max pudding layer. So now I'm changing the filters to 32. Now we don't want the input shape parameter. Okay, so we are having two set of convolution and max pooling. After this, I'm going to add a layer, that is flattening layer. That's it. Okay, so now we created the convolutional layers. Now it's time to connect the ANN model. Okay, so for creating the ANN, we'll have the dense layer, right? In the dense, what we'll do, we'll give the units. Initially we don't know how many features will come, so let's take the units as 500. Okay, so because we don't know how many features will come in the flatten layer after the flatten layer, so we're planning to have 500 neurons after this layer. Okay, so and then we'll give the activation and kernel initializer. Activation as relu, and we'll give the kernel initializer uniform. Okay, so now I'm going to add another hidden layer. Okay, and another hidden layer, or just one hidden layer itself. So we'll decrease the unit maybe 64 and then we'll have the 4 units, because we have 4 fruits here. Apple, we have banana, mixed orange, right? So we have 4 labels, that's why I'm having 4 units here. Okay, okay, instead of 500, I think give the multiples of 64, maybe like 256. Let's see what happens. Okay, so I'm having on the output layer, we're having 4 units. So you want to give the activation not sigmoid, you want to give the activation as softmax. Okay, because we have two or more than two labels here, so we'll use softmax. We don't want kernel initializer. So that's it. So now we got the neural network. So we have created the neural network. Now it's time to compile our neural network. In the compilation, what we'll do, we'll give the loss function. So the loss function will be uh, categorical cross entropy, because we have more than two categories. If you have two categories, then you can use binary cross entropy. Now we have more than two, that's why, because we are going to use categorical cross entropy. Cal underscore cross entropy. Okay, and we'll put optimizer. We'll use the Adam optimizer. Okay, and we give the metrics as accuracy. Okay, that's it. So after compilation, we want to fit our model into the dataset, training dataset. X train x underscore test, and we'll give the batch size. Batch size of let's say 50, and number of epochs will be, let's give a small number of epochs, 25 will give. Okay, so that's it. Now we'll run this program. Let's see what happens. What is this? Okay, we forgot to put dot here. here as well. As you can see here in the TensorFlow, it's suppose if you have a GPU, you want to install the Qdot application. After installing the Qdot application, the TensorFlow uh, will access the GPU. Okay, I'm just having this warning because I don't have the Qdot installed. What is this? Make sure all arrays contain the same number of samples. Data cardinality. What is this? Okay, it should be white test, not X test. That's white train actually. Shapes none, comma one, comma four. Yeah, in my system it will take long time to run this epoch. The accuracy is too less. Okay, I think no, we'll stop this training. Okay, I think I think maybe the problem in the size of the data is too small. Okay, the training will take some time. So if you have any doubts, you can ask now. It's not getting. No, no. Maybe change the test size or random state. Any doubts you have? And we'll end up the session here. Any doubts? Oh, so we'll end up the session from here. Any doubts you have, you can ask now. So the data set you can find it in Kaggle. We have a huge data also. Uh, Try with the huge data because we have a small number of data, right? So that's why maybe it's keeping a low accuracy, or it may be a fault in number of filters or maybe units. You just want to tune the parameters and then you will get a better accuracy. Okay, so we'll end up this session. We are bigdatahandson.com, our website bigdatahandson.com. So first let me start this. Yeah, my system is hanging. Yeah, I will stop this. Yeah. So now you can visit our website, or if you have any doubts, you can message in this number 979988844, or you can send email through support@bigdatahandson.com. And our previous videos will be uploaded in our YouTube channel. If you subscribe to our channel, you will get the updates. So tomorrow we'll see recurrent neural network, the third neural network in the deep learning. Oh, it's not responding. Okay, so we'll see tomorrow.